Chapter 5, Section 6, we are continuing our pursuit of standard number 7, and we are going to add and subtract, and of course reduce, our rational algebraic expressions. Now when we do this, remember from elementary school that when we're adding or subtracting fractions, there are essentially two cases. Case 1, when the denominators are the same, and case 2, when the denominators are not the same. When they are the same, we're going to add or subtract the numerators, keep the denominator, don't change it at all, and simplify our results. However, in the more difficult case, or the one that takes a little bit more work, when the denominators are not the same, you have to find the least common multiple, but when we apply it here for the denominator's sake, we call it the least common denominator, or LCD. Then we need to convert each fraction into an equivalent fraction that has the LCD as its denominator. We do that by multiplying by a form of 1, because multiplying by 1 does not change it. Then we can add or subtract the equivalent numerators, and then we can simplify our results. So let's start out with one that's fairly simple. All the denominators are the same, so we keep the denominator, add or subtract the numerators. 4 plus 2 is 6 minus 1, which is 5. We have to reduce that, so 15 could be written as 3 times 5. And any factor in the numerator, that's the same as any factor in the denominator. That divides out to 1, and we're left with our answer of 1/3. So now that we've seen a nice numerical example from our past, let's look at an algebraic example where the denominators are the same. Still the simple case here. We're going to keep the denominator. Only be careful, because when you're subtracting the numerator, it's usually as a polynomial. And I suggest we don't subtract polynomials, just like we learned in Chapter 4. Instead, we add the opposites. So I would like to add the opposites of x minus 2, just to be on the safe side. So doing that, distribute out that negative symbol as negative x plus 2. The denominators are the same. I'm going to keep it. We're going to add the numerators, 4x plus 5 plus the negative x plus 2. Collect our like terms. 4x minus 1x is 3x. 5 plus 2 is 7. And then the denominator is x plus 3. Now, I would go to factor the numerator completely, but it doesn't. Factor the denominator completely, but it already is. Any factors the same in the numerator and denominator would reduce, but there are not any, so that's my answer. For example, 1b. All right, let's start out with something where the denominators are different. 7x over 8 plus 5y over 12x. First step is to find the least common multiple of 8 and 12x. And since we're referring to the denominators, we will find the LCD, least common denominator. All right, 8 is 2 to the 3rd power when we do a factor tree. 12 is 4, which is 2 squared times 3 times x. To find the least common denominator, given a choice between 2 to the 3rd or 2 squared, we take the larger exponent, 2 to the 3rd. 3 shows up, we take it. X shows up, we take it, since those are the largest exponents that 3 and x show up with. And our least common multiple, or least common denominator, is 2 cubed times 3 times x. Quite often, although this is 24x, we might find it beneficial as problems get more difficult to leave it in its factored form. So instead of referring to the LCD as 24x, I'm going to refer to it as 2 cubed times 3 times x. And I'm going to factor the denominators completely. 2 cubed for 8 and 2 squared 3x for 12x. Now what I need to do is to write the denominator I want. 2 cubed times 3 times x. That's the least common denominator. To transform my fractions, or my rational expressions, into new equivalent ones that have the LCD, I'm going to look at what I have and what I want. The first rational expression has 2 to the 3rd. I want 2 to the 3rd times 3x. You can see that what's missing is the 3x. So if we multiply numerator by 3x and denominator by 3x, anything divided by itself is 1. We're multiplying it by 1 to change the way this rational expression looks, but not to change its value. Let's do that right away before we forget. 7x times 3x is 21x squared. Then the second fraction, I've got 2 squared 3x. I want 2 cubed 3x. So what's missing in this particular situation is a 2. So we need to multiply numerator and denominator both by 2. Anything divided by itself is 1. Multiplying by 1 does not change its value, but in this case the way it looks, 5y times 2 is 10y. Now that we have the common denominator, now we can go back and simply say keep the denominator, that's common, and let's go back to calling it 24x, and add or subtract the numerators depending on what the problem says. So that's 21x squared plus 10y. As we look to see if there's a greatest common factor in the numerator, or if the numerator can be factored at all, the answer to that is no. If there are no factors in the numerator, then there is nothing to reduce or simplify it by. All right, let's try adding 3 rational algebraic expressions together. That means we need to get an LCD between all 3 of these denominators, 2x, x squared minus 1, and x plus 1. So let's factor each denominator completely. 2x is in its prime factorization already, 2x. Difference of 2 perfect squares factors is x plus 1, x minus 1, and x plus 1 cannot be factored, so let's think of it as a factor. To find my least common denominator, if a factor shows up, we want to take it, so 2 shows up. The largest number of times 2 shows up is 2 to the first power, we take the 2. X, there are no other x's, so we're going to take it, x to the first power. I have a choice between x plus 1 to the first power or x plus 1 to the first power. We take the one with the larger exponent. Well, they're both the same, so we take one of them and ignore the other. And then x minus 1 shows up. We take that. That's going to be our least common denominator. So here's what I want the denominators to be. 2x, x plus 1, x minus 1. Here's what the denominators are. 2x, x plus 1, x minus 1, and x plus 1. To see what's missing, the first fraction is missing the x plus 1 and the x minus 1. So I'm going to multiply both the numerator and denominator by x plus 1, x minus 1. And before I forget, 1 times x plus 1 times x minus 1 is the x plus 1 times x minus 1. Second rational expression is missing the 2x, so we'll multiply numerator and denominator both by 2x. Numerator, 5x times 2x is 10x squared. Denominator gives me the LCD. Third fraction, I have the x plus 1, but I'm missing the 2x and the x minus 1. So we need to multiply both the numerator and denominator by 2x times x minus 1. In the numerator, 3 times 2x is 6x. That will finish multiplying by x minus 1 momentarily. So let's continue to simplify these numerators before we forget. Do not, because I have seen students do this, go, oh look, the x minus 1s cancel out, and the x plus 1s cancel out. Sure they do. That's what we started with. So unless you want to dig a hole and fill it right up for no good purpose, let's multiply the numerators before we forget. So x plus 1 times x minus 1, they're conjugates. We multiply the first to get x squared, the last to get negative 1. We already have our 10x squared. Distribute out our 6x to give us 6x squared minus 6x. We have the common denominator, so we're going to keep it. And we are going to add or subtract all the numerators, remembering that they are polynomials. So let's go through this. 10x squared plus 6x squared is 17x, plus 1 more. So 1x squared plus 10x squared plus 6x squared is 17x squared. Negative 6x plus nothing else like it is negative 6x. My constant negative 1 plus no other constants is negative 1. My numerator does not factor. You can try trial and error all you wish with all the combinations of 1 and 17 and 1 and 1. You will not do the outsides insides and end up with a negative 6. Since my numerator will not factor, I know that my rational expression will not reduce or simplify any further. All right, let's look at subtraction. And this is our last example of today's lesson. We need to find the common denominator, so let's factor each of these denominators. We need to be good at this. FOIL backwards, that's going to be x minus 6 times x minus 1. Second denominator, FOIL backwards, is x minus 6 times x plus 1. So the LCD, in this case, x minus 6 shows up, we're going to take it. Only one of them and ignore the other. We're going to take the x minus 1, we're going to take the x plus 1. Those are the three factors we want in our common denominator. We need to look at what we currently have as our rational expressions and what we want to have, see what's missing, multiply them by some form of 1 to convert them to their equivalent expression with the common denominator. So I've got the x minus 6, x minus 1. What we are missing is the x plus 1 term. So let's multiply both numerator and denominator by the x plus 1. And let's FOIL it out now. 2x times x is 2x squared. Outside is 2x, inside is 1x, that's 3x, and last is 1. And then we're going to do the same, find the equivalent here. We have the x minus 6, we have the x plus 1. What's missing is the x minus 1 factor. And let's FOIL that out now. X times x is x squared. Outside is negative 1x, inside is positive 3x, that's positive 2x, and last is negative 3. So we've converted our fractions from their previous form to an equivalent form where they have the common denominator. Now we're going to subtract the numerators, but again, be careful, don't subtract. Instead of subtracting, we're going to keep the denominator, and instead of subtracting, we're going to add the opposites. So instead of subtracting, it's going to be plus negative x squared minus 2x plus 3. When we simplify, 2x squared minus 1x squared is 1x squared. 3x plus negative 2x is x. 1 plus 3 is 4. That numerator does not factor, because if it did, both signs would be plus, and we would want factors of 4 that add to 1, and there are no factors of 4 that add together to give you 1. Since the numerator will not factor, then there are no factors to reduce. That is my simplified rational expression, and that's our look at adding and subtracting rational algebraic expressions.